Hey everyone, Mr. Hauk here. In today's video, we're going to be deriving the double angle formulas. Now today's video is going to be relatively short. We're just going to be going through the proofs for the double angle formulas, and we're going to be using the sum formulas for sine, cosine, and tangent to do it. Okay, so just as a reminder, here's our addition or sum formulas for sine, cosine, and tangent. And let's go ahead and try to prove these double angle formulas. So the first one that we want to prove is we want to show that sine of 2 theta is equal to 2 times sine theta times cosine theta. So the way that I'm going to approach this is I'm going to take sine of 2 theta and I'm going to rewrite it as sine of theta plus theta. So I'm rewriting 2 theta as theta plus theta. And now that I'm rewriting it as a sum of two angles, I'm going to go ahead and label each angle alpha and beta. So alpha and beta are the exact same angle. They're both theta. And if we follow the sum formula for sine, I remember the sum formula is sine alpha cosine beta plus cosine alpha sine beta. Let's plug in some pieces. Both alpha and beta are both theta. So this is going to give us sine theta cosine theta plus cosine theta sine theta. Now, sine times cosine and cosine times sine, these are really the same thing. Remember that multiplication is commutative. So this is really 2 sine theta cosine theta, which is exactly what we wanted to prove in the first place. So we're done. End of proof. Okay, so again, pretty easy concept. We're using the fact that 2 theta is the same as theta plus theta, and then we have it rewritten as a sum of angles. We can use the addition formula or the sum formula for sine. Let's apply the same concept to both cosine and tangent. All right, so the next result that we want to prove is that the cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. Again, let's start with cosine of 2 theta. And let's rewrite cosine of 2 theta as cosine of theta plus theta. So again, we're rewriting as a sum of angles. Both angles, alpha and beta, are both theta. Well, we know that for the sum of cosine, or the sum of angles for cosine is going to be cosine alpha cosine beta minus sine alpha sine beta. Well, again, both alpha and beta are theta, so this is really cosine theta times cosine theta minus sine theta times sine theta. Well, cosine theta times cosine theta, that's cosine squared of theta. And sine theta times sine theta is sine squared of theta, which is exactly what we wanted to prove. The cosine of 2 theta equals cosine squared theta minus sine squared theta. And just a little note on notation, just to make sure everyone's aware of this. When we say cosine squared of theta, or sine squared of theta, or tangent squared of theta, or whatever, that really just means cosine of theta times cosine of theta. Okay? All right, now let's do tangent. So we want to show in the last one, this last example, that the tangent of 2 theta equals 2 tangent theta divided by 1 minus tangent squared of theta. Once more, let's start with tangent of 2 theta. And let's rewrite it as tangent of theta plus theta. Okay? Once again, both alpha and beta end up being theta in this case. And we know that for the tangent, the sum of angles for tangent is tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. Well, plugging in the pieces here, it's going to be tangent theta plus tangent theta. You can hear my daughter's laughing in the background there. 1 minus tangent theta times tangent theta. And if we simplify this, well, tangent theta plus tangent theta, same term, so it's really 2 tangent theta the denominator, tangent theta times tangent theta is 1 minus tangent squared of theta. But that's exactly what we wanted to prove, that tangent of 2 theta equals 2 tangent theta over 1 minus tangent squared theta. All right, so these three results are called the double angle formulas for sine, cosine, and tangent, named, of course, because you are doubling an angle. So if we can find an angle on the unit circle and double it, then we can represent it in these three ways. So again, pretty short video, just 3 quick proofs. In the next coming video, you'll be seeing these actually put into action to do some calculations.